Again, 7, 7, 7, 8. Last one we're going to do today. I would have liked to have done more. We just never have enough time to do everything. Okay, and let me show you a negative omega. So we're going to look at question 13. I did make this one a little bit harder, so I did modify it a little bit, and we're going to do it. We can handle it. I'd rather play it hard in class. You can go back and watch the videos and softball it in class, and then you're lost at home. Okay, so y equals -3 sine of a -2x plus pi over 2, and then I just tacked on a +1 there, guys. That way I've shown you, like, this is the hardest possible case you can get for sine, because you've got a negative omega, you've got a negative out front, you've got a number out front, you've got a horizontal shift, and you've got the +1. I mean, I've thrown it all in there, so it's all there. Okay, so sine and cosine still are not too bad. All right, the key when you have, and you're looking at this and you're like, wait a minute, there's omega currently, and the book does not want you to use what? A negative omega, because then everything doesn't line up nicely like it's supposed to. All right, this is where you have to factor, and you have to use your even odd properties, which is why I don't like to give this on the exam, but you will see some of these on the homework for sure. So what you want to do, you can't have a negative omega, so you got to get it out of there. So this is how you're going to handle it. -3 sine, go ahead and put a bracket here. And you're going to factor out a negative out of those two terms. You're taking a negative out, which corrects this one, because remember, factoring out a negative is like, think dividing each of those by a negative, because you're basically reversing it there. So that would become 2x, right? But then what happens, this one becomes what? A minus. Now you can see it. If you redistribute, do you see that you get what you have above? So you know you're correct. So just change the signs, all right? And then we still have that kind of annoying what? +1 just sitting out to the side. Is everybody all right with that? Okay, now I picked a good one because cosine is a piece of cake. With cosine, all you have to do is just drop the negative now and just work with 2x minus pi over 2. Why is that? Because cosine is what kind of function? It's an even, right? Which we think kind of like positive. Even meaning that you just drop that negative, it's done. Sine is not an even function, it's an odd function. So what you do for sine is you take the negative and you do what? Move it to the front. Are you guys okay? And then you drop it in the argument. So you wind up getting 3 sine of 2x minus pi over 2 and then +1. You guys got it? Now remember, if you had cosine instead of sine, you would not have lost the negative in the front. You just would have had the same argument in here, but you would keep that negative out front. Make sense? Okay. You lose the negative because it's odd. Is everybody good there? Yes. No, okay, I'll give you a second. All right. So that's how you handle a negative omega. And now for everything else, you're going to ignore this one and you're going to work with this one. Okay? Okay. Now, the truth is, once you get that straightened out, it's not that bad. It's just, this is good practice. This is more how you would see it on the test, because I'm not going to be mean to you and give you a negative omega. So this is kind of where you would start with the test. But for homework, I do want you to know how to handle it. That's really why we want those even odd properties. That's why I even bother to go over them, is because it does get you out of that sticky situation with the negative. You guys all right? Okay. Okay, so moving over. Remember, the sine and cosine we like because we just make a walk around the unit circle. And it's really nice and easy. So I'm going to go ahead and mark all these. And just put my points in. everybody okay with that? Okay. All right. So now that we have this, do you guys see that the omega is what? 2, correct? So to get the period, it is sine. So remember, the only one you're going to do with just pi is tangent or cotangent. So this one is sine, so you're going to do 2 pi over omega. So it'd be 2 pi over 2, which is what? Pi. Now you're going to do your spacing between your x values, which I don't know why I did it backwards, because we normally just call this our what? Intervals. And we always take the period and divide it by 4. So for us, what do we get? Pi over 4. Okay, then what else do we, oh, start and end, right? We get start value, end value, so forth. And you could get I think Math Lab is for sine and cosine going to want the phase shift. So that's fine. So when you get your start value, if it's sine or cosine, this will also be what the book is calling your phase shift. And so what you do is you take your argument for everybody except the last 2 we graphed, which was secant tangent, you set it equal to what? 0. So just take your argument, set it to 0, and that'll get us going. If you guys ever want to move on, stay on the same line in mathematics, and you already have an equal to sign, you use something called an implication arrow. So if you say implies, then you can kind of keep everything on the same line because you already have an equal to. Do you guys see it? So that's up to you. So I like to really usually go vertical, but I just, I don't have the room. So what you would do, you would add the pi over 2 over, so you'd have 2x equals what? Pi over 2. Does that make sense? And then I would multiply by 1/2 to get x isolated. Notice it'll cancel there. So again, you could use your arrow. You would say x would be what? Pi over 4. So you're going to start this thing at pi fourths. Make sense? Okay. We'll go ahead just because we can, but you don't have to do this on test. We'll get the end value. I'm going to prompt you for a lot of this stuff on the test and say find this, find that, to kind of help walk you through it, but I try not to make it too much. All right, so to get the ending value, again, you're going to take your argument, and we know normally sine runs from 0 to what? 2 pi. So we're going to take our 2x minus pi over 2. We're going to set that equal to 2 pi. Again, I'll add the pi halves to both sides. So I'm going to have 2x equals pi over 2 plus 2 pi. Let me think of that as over 1 and get a common denominator. And so that winds up being 5 pi over 2 over there. Does everybody see it? 2 times 2 is 4 pi plus another pi is what, 5? So it's 5 pi over 2? Okay. And then I've got to divide by what? 2. Yep, you're right. So we're going to have 2x equals 5 pi over 2, or multiply by the reciprocal, same thing. So I'm going to multiply by what? The 1/2 to get rid of the 2. So we should be ending at 5 pi over 4. Got a headache yet? 'Cause this has been kind of heavy. I'm kind of over it, so I know you guys really got to be kind of over it. So, okay. All right, let's get it done. So now we're going to make our key points. Let me grab the function that we altered. This is the one we want to work with. Okay, I'll just kind of start gathering it. So here's our key points. I know we're not starting at 0. We were starting at, where's my start value? Pi over 4. What was our spacing? Our spacing was, oh, I love these when they're the same. It's pi over 4. That's what makes it easy. So our spacing is going to be pi over 4. Pi over 4 is how much? 2 pi over 4, which is really what? Pi over 2. 2 pi over 4 plus pi over 4 is how much? And then 3 pi over 4 plus another pi over 4 is 4 pi over 4, which is pi. And then 4 pi over 4 plus pi over 4 is how much? 5 pi over 4. That's 5 key points. Was that our ending value? Was 5 pi fourths, right? Okay. I'm going to real quickly, I'll come right back, but let me grab my unit circle here, or my points on the unit circle. So I know we're going to need these. Everything's positive, so that makes it a little bit easier as well. So let me kind of just make this smaller. Okay. And okay, so we know we should be making our walk around the unit circle, right? Counterclockwise. Let me plug in the pi over 4. So we're going to have y is equal to 3 sine. We're going to replace x with pi over 4 minus pi over 2 plus 1. But I know I should be starting at what? 0, right? But you are, because those cancel. You're left with 3 sine. You've got pi over 2 minus pi over 2 plus 1, which is what? 0. So that's good. So we've got 3 times the sine of 0 and then plus 1. Make sense? We know 0 is right here. We're dealing with these points. Sine is which coordinate is the y, so it's going to be 0. So you're going to have y is equal to 3 times 0 plus 1, which is what? 1. Easy enough? Yeah. We like sine and cosine. They're easier. Okay, so let's look at everybody okay with that? Because I know I'm kind of rushing here. We know the next one should be here, correct? We're going to plug in. We're going to make sure that's true. So I'm actually going to erase this one. And I'm going to come back. And now I'm plugging in this pi over 2. So we have 3 sine. We have 2 times pi over 2 minus pi over 2 plus 1 is 3 times the sine of 2 pi over 2 minus pi over 2 plus 1, correct? What's 2 pi minus pi becomes what? Pi over 2. So we're right. All right, and we know which coordinate right here? The y, which is 1. So you've got y is equal to 3 times 1 plus 1 gives us what? 4. Everybody got it? Next stop should be here, correct? So let's make sure. Are you guys okay if I erase? Okay. No? Okay. Yes? No? Okay. All right. All right, let's plug in the 3 pi over 4 next. So we're going to do 2, working with this one. We've got times 3 pi over 4 minus pi over 2, and then plus 1. This will cancel down to a 2. So you've got 3 times the sine of 3 pi over 2 minus pi over 2, and then plus 1. 3 pi minus pi is what? 2 pi divided by 2 is pi. You guys all right? Again, what's your y coordinate here? Yep. And you'll start seeing a lot of patterns, you know, but it's a balance between how much do I want you to memorize, and I want you to know a lot of it, but then I also want you to be able to dig it out if you needed to, right? If things change, you would know how to do the graph. So, okay. All right, let's look at the next one. Now we're plugging in pi. You guys okay if I erase? Okay. We know our next stop should be at what, 3 pi over 2 ultimately. So let's see. We're plugging in pi here. So we've got 2 times pi minus pi over 2 and then plus 1. So we've got 2 pi minus pi over 2 plus 1. I'm going to go ahead, get a common denominator here, times 2 times 2. Sure enough, 4 pi minus pi is what? 3 pi over 2, and then we still have the plus 1. Are you guys seeing it? So like we said, it should be right here. Y coordinate there, what is it, guys? So 3 times negative 1 plus 1 gives me what? Negative 2, right? We should now be back at the 0, correct? Which we already know turned out to be 1, but we're going to run through it. I just want you guys to see it. How are you if I erase? I think you're still copying. Let me give you a minute. Okay, so I had 2 pi minus pi over 2, right? Had to get a common denominator, so I multiplied right here, top and bottom, by 2, which gave me 4 pi over 2 minus pi over 2. You see it? And you get 3 pi. And you guys, listen, on the test, just write it all. I mean, if it's probably better to, I always, especially when I'm learning something new, I write everything out. And it helps me, too, when I grade, because then I'm like, okay, you had the right idea, you just messed this one part up, you know. Sometimes I don't know what's going on, then it's bad for you, because I'm like, what are you doing? And I don't understand it. Okay, so let me come back and plug in the last one. 3 sine, what are we plugging in? 5 pi over 4. So 2 times 5 pi over 4 minus pi over 2, and then plus 1. That will cancel down. 5 pi over 2 minus pi over 2, and then what? Plus 1. Now look at that. 5 pi minus pi becomes what? 4 pi over 2, which is 2 pi, which it should be. We should have been right back here. Sign there is 0, correct? Which gives you 1. You getting it? You got it? Okay. All right, good, good. All right, let's plug in our points. Let's do it in orange this time just to be different. So we're starting at pi fourths. They should be equally spaced. Next one was pi over 2. Next one was 3 pi over 4 pi. And then 5 pi over 4. Let's see. Okay, so pi fourths we had 1. Pi over 2 we had 4. 3 pi over 4 we had 1. At pi, what did we have? Negative 2. So right now we're looking like this. And then 5 pi over 4, we were back at 1. Does everybody see it? Yeah. Yeah. Okay, now remember, you guys, if you'd like, for sine and cosine, what can you do? Just attach the arrows and just do your domain as all reals. That's fine. If not, if you want to leave it closed off, just do pi fourths to 5 pi fourths. I don't care. Whatever you see on the test is fine. Just make sure you have your notation properly. So for domain, we'll put all reals because I did put the arrows on. What do you guys see for the range? Where are your y's?
-2.
Yeah, -2, and actually I should do brackets here. -2 to what? To 4. Yeah, you guys are doing fine. All right, that is all the test material. You guys got it? I'm sure that was a lot today, but okay. All right. Let me turn this off, and we're going to talk about the test.